Hello again, I'm Mr. O'Rourke, and in this video I'm going to talk about how the periodic table is arranged. And the basic arrangement of the periodic table comes from how the electrons are arranged, okay? And this grouping will make lots of sense once we go through it. Okay, each row across we can think of as an energy level, okay? Each row across is how many electrons each energy level can hold as we go through. There's one thing with kind of elements, okay? To have 8 electrons in its outermost shell of electrons is the ideal arrangement for stability in the atom. So they all want this 8 electrons in the outside. The only exception is the first energy level because it only holds 2. Now, there's 7 levels that they can happen on. Each level can hold a specific amount of electrons. 2 in the first level, 8 in the second. You can hold up to 18 in the third, 18 in the fourth, and it goes on and on, okay? So we'll get to that as we move on. So there's different numbers in each one. The electrons fill out in a very orderly way, okay? It's a very predictable, orderly way, and we're going to go through that exactly how they fill out right now. First thing we're going to look at is hydrogen and helium, the first 2 elements. You can see they fill out on that first energy level, and it can only hold 2. First energy level can't hold anymore. So when we get to lithium, lithium would have 3 electrons. Now, you can't fit another electron on there. You start filling out the next energy level. So when we look at the periodic table, first energy level is full, and then the lithium. Well, now, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, that gets us to our magic 8 number, okay? The second level can only hold 8. It can't hold any more than 8. So once we get to that 8 in the second level, okay, the next electron, the next element you're pushing another electron on, goes here. It goes up on the third energy level. So I'm going to go to my graphic here. We have beryllium, okay, as we go across the periodic table. Then we jump across that gap to boron, carbon, nitrogen, oxygen. Fluorine is 7 electrons, 2, 4, 6, 7. The next one is neon. That's 8. It's stable. That's where it wants to be. Okay? Can't hold any more anyway. The next electron for sodium goes on the next energy level. The next element is magnesium. After that, after magnesium, okay, there's this jump again. And we get to aluminum over here. So we come up, we go to aluminum, it's jumping across, silicon, we get phosphorus, sulfur, chlorine. You can see we're only missing one more. We have 2, 4, 6, 7. We need one more for the 8. We're happy. Now this level can hold 18. It can hold 18 electrons. But once we get 8, it's the most stable it can be. The next element that comes in is potassium. It can hold 18, but since it's so stable, it pushes it out to the next energy level. So you have to go up to here. So when we look at the periodic table, okay, you get from argon, even though it can hold more, you go to potassium. The next one is calcium, okay? So when we look at here, we go to calcium. Now, here's where the tricky stuff starts. After potassium, the next one is scandium. Now, as you can see, that's on the third energy level. When we look at the periodic table over here, we get the scandium. That electron goes on the third energy level. Everything from here over to zinc, scandium to zinc, these 10 electrons are going to go down to the third energy level, which will make 18. Okay? It has the 8, doesn't want any more, pushes the next 2 up to the 4th level. Now, the 4th level and the 3rd level, it gets squirrely. You start to put these electrons, go on for these elements, go on the 3rd energy level. So what this says is the outermost shell of electrons has 2 for all of these elements. That makes a huge impact, okay, when we talk about the things, because these are known as the metals, okay? Because the two are the valence electrons, the two guys on the outside that they're involved in chemical bonding, these are all metals because of that electron configuration. As a matter of fact, it kind of goes up from the metals and non-metals kind of go in a diagonal way like this that you've seen. Everything from here over is a metal, okay? And it's all because other electrons gets pushed to lower levels and the outside only has two. Now, once we look at this again, okay, if we keep filling in the electrons as we go by to manganese, iron, cobalt, nickel, copper, zinc. Now zinc is the 10th one, okay, in here. Zinc is the last one. When you get to gallium, that's full now. There's 18 there, it can't hold any more. They have to go on to the next area. So look at this. Now we start filling out, like I filled out the blue, there's 6 blue. Gallium, germanium, arsenic, selenium, bromine. Now we have 7. There's only one more we need to achieve stability. Krypton. Again, when we look at our periodic table, krypton is at the end. We've achieved stability and we're good. So the next electron for the next element, rubidium, when it comes in, it can't fit on there, even though it can hold more electrons than the 8. Same way from the last time, it will push it up to the next level, and the cycle repeats itself, okay? It just keeps going. You get your rubidium and your strontium. Okay, so this is how that these spill out. Because all the other elements, the next 10 elements, electrons spill out on here, because it has 2 electrons in the outermost shell, it acts like a metal. And that's why there's so many metals on the periodic table compared to the nonmetals. All right, let me go back to the periodic table. So when we look at what happened, okay, every time we jump to a next level, we can use the periodic table to tell us how many electrons are in the outermost shell or ring. In this group, you all have 1. There's 1 in this group. Because when we look back at the, here, we go back to the beginning, okay, hydrogen, lithium, okay, the next one, sodium, sorry, sodium, you have 1 out there. So when we look at the periodic table, hydrogen, lithium, sodium, they all have that 1 lonely electron. Everything in this column will have 2 lonely electrons out in that outermost ring. We skip across this gap, everything here will have 3 electrons in the outermost ring. Here we'll have 4, 5, 6, 7, and then 8. The only difference with this, they all have 8 except for helium. Helium, because that energy level can only hold 2, is kind of like the oddball, but it acts like everything in this column chemically because it has a full complement of electrons for that energy level. So, you have all this. So everything in this column is going to react chemically very similar to everything else. Okay, it's not exactly, because as you move out, everything in this column will react similarly chemically because of the way the electrons are arranged on the outside. So, anything in this first, if we draw the chemical symbol, lithium, okay, and we say how many electrons are in its outermost shell, okay, there's only 1. I can put it in there. Well, sodium, same thing. How many electrons are in its outermost ring? 1, because they're the electrons that are integral in chemical bonding. So they're the only ones we care about. The inner electrons don't really play much of a role, so we're not concerned about them. If we go to beryllium, that has 2 electrons. 1, 2. Magnesium, again, if we're going to represent the electrons, it has 2 electrons around it. Boron has 3. 1, 2, 3. Carbon would have 4. 1, 2, 3, 4. And everything in this column would. Silicon would have 4 as well. Would have 1, 2, 3, 4. Nitrogen, you get into the 5. 1, 2, 3, 4, 5. Okay, everything down here. Oxygen would have 6, fluorine 7. So we can represent it really easily by just putting the valence electrons, because they're the only ones that we really care about when we talk about chemical bonding. Now, the main reason I want to talk about chemical bonding real quick and be a little bit thorough is because we're going to get into substances and mixtures coming up, and knowing the difference between them. This is kind of key. Understanding how things bond chemically will give you a substance. Okay, elements and chemicals that are bonded together chemically, they're substances, they're pure, and they're not mixtures. And we'll get into that when we get up to there. So, hopefully this was helpful in seeing how the periodic table is arranged, where the electrons are, and in the next video I'm going to show you how they actually work with chemical bonding. Thanks for watching. See you next time.